And what did we learn so far in section 3.3? When is a function increasing? We saw a function is increasing when? The first derivative is positive. And a function is decreasing when? The first derivative is negative. All right, so typical homework problems are going to look like this. F of x is x cubed minus 6x squared plus 15. Determine the intervals where f of x is increasing and decreasing. Decreasing. And classify all critical points. Now, what do I mean by classify? That was going to be my question. Good question.
Absolute, local.
You need to tell me if it's a minimum or a maximum. And at this point, the best we will be able to do is say relative minimum or relative maximum. We won't know if they're absolutes yet. The first derivative test, which is what we're going to use, it only tells you about relative mins and relative maxes. We'll have another theorem later on that tells us about absolute. We know about absolute if we only have a closed interval. If I gave you an interval like -2 to 5, then you could tell me absolutes, but not without an interval. All right, so what do? We take the derivative. That's almost always the right answer. The derivative is 3x squared minus 12x. Then what do? Set it equal to 0 to find the critical numbers. How do you solve that equation? 3x. 3x times x minus 4 is 0. So x is 0 or x is 4. What you do next is you draw yourself a number line. And you mark your two critical numbers. This breaks the number line into three regions. We've got the region bigger than 4, the region in between 0 and 4, and the region less than 0. You pick your favorite number bigger than 4. 5, 7, it doesn't matter. 57. I like 57 a lot. I'm going to take 57 and I'm going to plug it into the derivative. So I'm going to have 3 times 57 times 57 minus 4. How much is that? I don't know. What I do know, and the only thing I really need to know, is that it's a positive number, isn't it? 3 times 57, that would be positive. 57 minus 4 is positive. Positive times positive is positive. So I don't know what I get when I plug 57 in. I don't really need to know what I get, other than I got a positive number. That tells me when x is bigger than 4, my function is going to be increasing. So I draw an arrow like that to indicate increasing. My derivative was positive. Just for fun, let's plug in 5, because that one I can do in my head. 3 times 5 is 15. 15 times 1 is 15. Still a positive number. My function is still going to be increasing. I picked my favorite number between 0 and 4. 2.5. No, that's not my favorite number. My favorite number is pi. So we'll use pi. What's 3 times pi? 3 pi, which is positive. What's pi minus 4? I don't know what it is, but it's a negative number, isn't it? Because pi is 3.14 something, something, something. So positive times negative is going to be negative. So you don't really need to know the exact values, and that's something that bothers people. They always want to know the exact value. You don't need it here.
I have a question.
Go ahead.
So if you know that 0 and 4 are critical numbers, and so 4 is a critical number, and you know that on this side of 4 is increasing, doesn't that mean it has to be decreasing on this side?
Great question. The answer is no, and I'll give you an example in a minute.
Wait, points of inflection, right?
No.
That's correct. It could be something else known as a point of inflection. We haven't talked about those yet.
I was going to say discontinuities too.
Well, that's possible, but this problem was a polynomial, so we know we don't have any discontinuities.
So which one, why?
All right, so now we pick our favorite number less than 0. Negative 2. I plug negative 2 in. 3 times negative 2 is negative 6. Negative 2 minus 4 is also negative 6. Negative 6 times negative 6 is a positive number. Happens to be positive 36. But you really don't need to know the answer. All you really need to know is it positive or negative? And that makes it a lot easier when you do have to plug in fractions or decimals, because sometimes that happens. All right, so our answer would be increasing. X is less than 0, and x is bigger than 4, because that's where the arrows are going up. Decreasing. X is between 0 and 4. And then what's happening at 0?
There is a absolute minimum at 0 and 4.
I don't think there's an absolute minimum at 0.
Absolute maximum.
I don't think there's an absolute maximum either. The best we can say at this point is it goes up and then it goes down. So it's a relative maximum. I don't know if it's absolute or not. In fact, I'm sure this one is not absolute, because if I graph an x cubed function, what's an x cubed function look like in general? In general, they look like this. So I know I do not have an absolute maximum at 0. Best I have is a relative. All right, so we would say relative max at, if x is 0, what's the y number? Not 0. It would be 15. You plug 0 back into the original function. You always go back to the original function here. So a relative max at 0, 15. And then what's happening at 4? A relative min, because the graph is coming down. Then it gets to 4 and it turns around and goes back up. Relative min at 4, I'll use my calculator, I guess. 4 cubed minus 6 times 16 plus 15. I got negative 17. So there would be my answer. There's my increasing, decreasing, and I classified my critical points. All right, we'll do some more examples of this tomorrow. Not tomorrow, because tomorrow's lab day. We'll do more examples of this on Wednesday. And then we'll move on to the next section.